Okay, great. So first of all, thank you, Victor, and the entire FinOps Weekly community. And great honor to be in this kind of special event and conference. We've is especially happy, along with Cloud Dojo, to be a sponsor of, to be a platinum sponsor of this event. And this session itself, as you can see, we'll talk about FinOps and AI. And what I would wish to provide here is a practical guide to actually handling AI cloud costs. So first of all, a little bit about myself. I'm 7 years in the cloud and FinOps space. I was the CTO of Pileus, which was acquired by Anadot. Today it is called Umbrella Cost. And for the past 2 years, I'm the co-founder and CTO of Wiv. About Wiv, so we see ourselves as the ultimate FinOps automation suite. This means if you would like to do some FinOps automation, we've got you covered in this. And this comes into place with a rich FinOps workflow automation, an AI agent for analytics and also actions in your cloud environment, a human approval loop. So the automation wouldn't be fully automated, so you could have still controlling it, and a rich case management, which allows the monitoring of this entire environment of automation. As it gets in scale, it is very important to see how everything goes along. So what's in it for you in this session? As I've mentioned, it's a session about FinOps for AI. So I would like you to understand what drives your AI cloud costs, some practical methods to cut spend without slowing the innovation of AI, learn practical approaches to see clearly where your AI spend is going, and discover ways to keep your AI cloud cost under monitor. And I think the important thing in this session is that it also comes in other areas in FinOps, but especially in AI, there is a really deep need for FinOps inside the engineering, inside the very early part of implementing a new AI feature. You will see that FinOps involvement, even in the code itself, is very important. So first, a short disclaimer. We're talking about FinOps for AI, not AI for FinOps. This means model and tokens-driven costs, AI visibility, AI cost visibility, engineering choices, and smart optimization. AI for FinOps would be AI tooling that would improve your FinOps behavior handling. So first of all, the challenge. As we all know, cloud AI costs are surging out of control. So there was a report that was published and mentioned that average monthly AI budgets are set to rise by 36% in 2025. And also public cloud is the second most adopted AI platform after generative AI tools. This means that after all of the licenses and using of Cursor, ChatGPT, Claude, and so on, costs of AI in the cloud are one of the most popular aspects of AI. And the last thing, which in my opinion is the most important, only 51% of teams feel confident in their ability to measure AI ROI. This means that we implement AI features without knowing for sure that we're getting the right ROI for it. And we will see some reasons behind it, behind this vector. So why is this happening? Before we dive in to the reasons, first let's understand the pricing structure of AI, and we will of AI costs in the cloud, and we will take AWS Bedrock as an example. So first of all, we have a base formula. The total cost of the pricing of Bedrock comes from input tokens times the model rate. Model is like the LLM model, plus the output tokens times the model rate. And it is charged per 1,000 tokens, and rates vary by model type. As you all know, cloud have different pricing approaches, and so as AI cloud costs. So here we have the on-demand, which you all know, the provision, which you probably recognize from DynamoDB, from other AWS services, and batch, running AI LLM queries in a batch form. In addition to it, we have a few cost factors. As I've mentioned, the model type, storage, which certain features of Bedrock needs, data transfer that we all know, and regional pricing. So let's take an example, a request to Anthropic's Claude model to summarize an input of 11 tokens to an output of 4K tokens. If we will measure this example, the total amount of it will be 0.184, which is a lot. It's for one query. So if you will take this cost and scale it and think of it like in a fully deployed feature with lots of customers, this this basic equation can cost you a lot if you're not careful with the handling of it, or if you're not planning it correctly. So a few very obvious but important observations from what we just saw. First of all, just to clear things, it's input tokens plus output tokens. So people tend to think, okay, so I've inserted a really large input token, and this what causes me the high price. But the fact is that input token price is much less than the output token price. So we need to also take care of the output structure, and we will cover it in the next slides. And of course, models price can range significantly. So see the difference between Claude Sonnet 4 and Amazon Nova Pro. It's a really high difference, and think how much cost can you save just with these different models. So looking at this pricing model, we can see that this rise in AI cloud cost doesn't just happen in coincidence. And we can identify two main drivers that does it. So the first one is by the organization itself, how companies adopt and handle AI. And the second one is technical, how systems and models are built and used. So let's cover them. So organizational drivers comes from the following things. So first of all, AI hype and overuse. We have some kind of pressure, some companies, not everyone, to add AI everywhere. We have an idea, we have a new feature. Okay, let's see how we can add AI to it. Sometimes we think we will put AI, we will say, okay, we're going to use AI, let's think of which feature can use it. Also, we have sometimes a silver bullet thinking. We believe that AI can solve any problem. So it's around the same as the first bullet. We have some kind of an issue or a feature. Okay, AI can solve it. And in this area of AI can solve it, sometimes the solution process, the fast process is, okay, AI can solve it. For us, this matter is solved and we will use AI for it. This helps us to do a quick win of the problem, but in the long term, that's not right. It doesn't mean that the AI should have been used. Second thing is for organizational drivers are uncontrolled MVPs. So I don't know if you've witnessed it in your organization, but AI experiments scale much faster. So a developer can try a new feature that combines AI, and real quickly, this experiment, this feature can rise into high costs. And then the next step of it is that this experiment or this POC becomes a production without a clear goal and cost planning. And you know how production hits you hard. And uh, for like a few days running this POC that on a dev environment was running even with not that low cost, but relatively good costs, let's say. In production, it blasts, and you suddenly see a really rise cost because of this. So this also a really important thing to check. And lastly, shadow AI, which could happen in several organizations, just that a certain developer or I don't know who uses AI cloud spend without kind of a direct scope or a feature scope, and it just goes without noticing. Next is technical drivers. So the first one, which is the most trivial one, is token explosion. And when we think of token explosion, we immediately think, okay, we have long prompts, and that's right. And long prompts are the one of the reasons that causes this token explosion. But there are additional things that can contribute to it, like this anti-pattern of accumulated conversation history. So what exactly, say you have a feature of a chat, AI chat, and instead of keeping the conversation in a session, each time the user writes a new message inside the same chat session, you will add this conversation into the chat itself, into what is being sent to the AI. And this way, the context and the prompts are getting very large instead of just keeping what was already the history itself in the session of the LLM itself. Next thing that can cause token explosion is retries and loops. So for us at Wiv, we also developed an AI agent, and one of the things that we've seen that sometimes when a user query our agent, it goes into a loop of retries. It tries different tools, and these tools fail, so it tries different other tools, and this one also fail until it succeeds. So this pattern of retrying and failing costs you a lot. So it's something that needs to be taken care of to limit the loop and to check also why the tool is failing. And in addition to it, no token guardrails, no max token limits, no timeouts, no retries budget. This also creates a token explosion. Model usage. So model usage is combined first from model choice bias. We always default to the largest model. Why? There is a big announcement of the new, fastest, strongest model. We think that for us, this is the trivial choice, and we will almost immediately convert to this model inside our implementation. But as expected, this model comes with the highest cost. So we need to take this into account. Also, over provisioning. Sometimes let's take even this, the first example. Sometimes the largest model for us is the default model for any task that we have on our system. So even if it's the smallest task, like a short summary of text or generating some query, I don't know, we default to the largest model instead of matching the right model for this task. And lastly, for model usage, is that we don't need to use a model all of the time. So we can use code logic. So sometimes, and it goes to the organizational drivers, the default thing is to use LLM. But instead of it, we can think of how we can solve it with code logic, and it will be faster and cheaper. So this was the organizational and technical drivers, and what can we do about it? So as I've mentioned in the start of the session, engineering can do a lot of it. It's the first layer, and it's how we design, call, and optimize the LLMs. But also we have a very, I would say, a classic FinOps layer of how we track, allocate, and control the AI spend. So let's see it in action. So on engineering, we will focus on three aspects: call reduction, prompt engineering, and choose the right model. Call reduction, the equation is simple. Fewer LLM calls means lower costs. It's obvious. So as mentioned, code first approach. Not everything needs to be solved by AI. We need to challenge this assumption, and we need to think how we can use simple code logic instead of certain LLM calls. Second thing we can do is group or batch calls instead of multiple small ones. We could also use AWS Bedrock as we've seen, because it has a oriented pricing for this kind of calls. And of course, the cheapest AI call is the one you don't need. Prompt engineering. So again, it's very trivial, but I think the system prompt and the task prompt that we use for LLMs is the basic, but the most important thing that we need to go and iterate and try and make it as accurate as we can. Because this, in the essence, affect the cost and the output and many things inside this AI cost domain. And in this area itself, of course, we don't want to neglect how we structure and limit the model response. As you remember, the output tokens are pricier than the input tokens. So if we forgot on how we want to structure the output, we actually neglect the higher part of cost from our AI costs. And one very cool technique that we can also use inside the prompt engineering is prompt caching. So prompt caching saves part of your prompt in a temporary cache. It could be static parts like the system instruction, the context, maybe documents, and you benefit first from the token costs and also the latency because the model already caches the context for it, and it will work faster because it doesn't need to process the entire system prompt again. Lastly, choosing the right model. Avoid strongest model bias, as we've mentioned. Hold the temptation to use the strongest model, the newest model, until careful examination of it. Map models per task. Use dynamic model routing to pick small, medium, or large based on complexity. By the way, it doesn't have to be by complexity. It could be even by customer even or a feature. Apply some kind of a model routing. Just don't use the just default for everything and one strong model for everything. FinOps. So as you can see, FinOps aspects are relatively known. We're talking about visibility, budget control and alerts, guardrails, and automation. And let's dive in. So visibility, as you might know, we first need attribution. And we want to map spend of the AI costs to apps, teams, tenants, and so on. One example for it is using AWS inference profile, where you can create inference profile based on any attribute you would want. So you would know how much you're spending per usage, and you can assign the LLM that you're using, the model, to the tag itself. And this thing itself, this single thing can create attribution along many profiles and different aspects of your organization. Second thing in visibility is AI cost efficiency ratio. So we can measure AI cost per business metrics. And what I mean by this is first, think of it like the AI interaction per the feature in your organization. So if, for example, I have a very small feature, which is AI interaction, cost me a lot, maybe it doesn't need, is efficiency, maybe is not right. Maybe I need to switch to a different model because it's a small feature, because it's something that costs me too much and it's not effective business-wise. I need to ask myself if this is the right way that I'm using. And the same for customer. If I have like a very small customer, let's say, but his AI spend is very high, maybe I need to switch to a different model. Maybe I need to do some configuring for this specific customer, or the opposite, by the way. If it's a very big customer with AI needs, maybe I need to upgrade the model. Budget control and alerts. Of course, we want to set limits and thresholds on AI cloud costs. This will allow us to first to set the boundaries and to see and for the R&D teams that are developing, to see what are their limits and where do they need to work with the models itself. And of course, once these limits hit, we want to trigger the alarms for it so we would know about it. Guardrails and automation, it's kind of like the control the budget a lot, but on the infrastructure level, we want to apply rate limits to the model itself to enforce quotas. And we can automate by governing the environments and projects, checking for each environment, for each project, what was the AI cloud costs, checking if there is some kind of an anomaly. And we can do this for each feature, for each environment, for each project, for each customer. And we can also apply a low-value model discovery, so we can check AI workloads with high cost but low business usage, and again, shut them down or switch model for it and see the efficiency of them. So key takeaways of what we've just seen, what we've covered. First of all, the challenge we see, the AI costs are really rising up, and we don't know, we're not sure of the ROI of them. We saw that the drivers for it are first from the organization itself. We have AI hype, we have uncontrolled POCs and shadow AI, that we need to first understand if AI is the right solution for what we're implementing. And when we agree that this is the right solution, we need to prepare and think what is the right way to do it. And from technical aspect, we saw how token explosion hits and how we sometimes use inefficient model choices that drive our expenses. The solution, as presented, is a unified FinOps engineering strategy. First of all, on the engineering level, we have a lot of options to reduce the LLM cost, even in the code level itself. This is why I've said that in this kind of FinOps domain, FinOps needs to be applied very early when a feature is implemented. And after the feature was deployed, we want to govern with FinOps to map the AI costs with the right attribution. And of course, to implement budget alerts and automated guardrails to prevent runaway spending.
Okay, thanks. Let's give some reactions to Gil for the awesome presentation.
Thank
I
you.
think it was great. So there are some questions in the chat already. That one is that if you have a guide to estimate cost of an AI solution, that says, Victor, I see that this is based on codes on tokens, right? So what are your approach to this AI solution cost?
So I think we need to do a controlled experiment on the POC level and to understand and to try to anticipate what will be and to ask the right questions on the development phase. Sometimes we really rush to see that it is working. AI supply the solution, and then we say, okay, on production it will be okay. But we need to ask the right questions on the development phase, the right FinOps questions. And again, boundaries, and there is a lot of what if it jumps to this, and these questions lead to the right experiments. There isn't, it depends on the feature itself. But asking the right questions is the first step for it.
Okay, yeah, that's asking the right question and considering if the initiative is worth it is something that
Mhm.
definitely is something valuable to do. And then the other one is more. It's not about really about AI, but cost data from Azure is always a day too late. How can I alert when it's happening? I don't know if you have. You'll probably have some inputs on there, but
I think cost alert is like a cost latency is something that we're all familiar, mostly on the end of the month and the start of the new month. Um, I think that once we hit this alert, or we found this alert, uh, the problem is not the 1 or 2 days. It's like a much deeper problem. So uh, I don't know what is the exact delay, but if it's like a 1 or 2 days, I think it could be observed. But it's a known problem. Uh, we we need to know it as soon as possible, even if it's late a few days. And I think automation is like one of the ways to be aware of it, and to once even if it's late, like a few days, we need to know immediately when it's ready. When even if it's
Mhm.
late, so if you don't have the right triggering solution for it and knowing about it, it could pass a few weeks and you just notice it accidentally. So we need to acknowledge it and always um, monitor.
That's it. Yeah, totally. I think also that with the budgeting and setting those thresholds, and as you mentioned, automation, be ready as soon as I can. It's something that is super valuable for not
Mhm.
getting out of budget soon. So another question by Hamish is: I have seen a few AI implementations where revenue has not been tied to consumption and therefore cost. As such, return has been highly dependent on adoption. So, how have been people trying to project and understand the adoption curves or or customer population behavior? So, basically, I think to summarize a bit is how have you seen, or how can people do the connection between the cost and the real business value that an AI application is giving to the company?
Yeah, so I think it's something that we've covered in this session. First
Hmm.
of all, the AI services of the cloud providers provide certain mechanism to apply attribution. So once you can apply attribution, you can start colorizing areas of your AI cost. If this is this feature and and this customer or this team that is using the AI. And second thing is that we need to measure it and to see the usage of I don't, we need to provide some kind of we call it on the presentation the AI efficiency score uh, per AI feature to see how much it is being used on a business level and how much it costs us on AI cloud cost level, and create some kind of a ratio, and then start to compare all of these features to start seeing numbers and to see which one has the highest ratio or lower ratio, and to understand if it's beneficial or not.
That's correct. Yeah, I think that, or and some people say, yeah, or use time a real time solution. Definitely.
This was
Um,
for
yeah,
the
yeah, yeah.
previous question.
Yeah.
Yeah.
So definitely, I think that it's one of the most difficult parts, but yet is, as you mentioned in the presentation, and you mentioned now, it's one of the most important.
Mhm.
Because if you disconnect yourself, like your company, from the value that you're getting from the development, and you are not able to provide that,
Mhm.
definitely you need a way to standardize how to get value from that. And another one from Ajit is: are there any FinOps challenges you have seen over AI producing non-deterministic output, an AI hallucinated, and are there any FinOps solutions to catch it sooner and avoid cost?
I haven't seen like FinOps solution that catches the hallucination of the AI. Uh, we did seen like on our solution anomalies and catch the anomalies of AI model usage on several of our customers that was not aware that suddenly they've used a certain model and the cost of it was so high in like someday it started to peak really high, and they're just not aware of it. And then when we've informed them, they consider the chain of thoughts that I've mentioned. Is it the right model that we need? Maybe we need a weaker model to provide additional cost, and the entire process of improving the FinOps process that was applied into this AI usage.
Okay, I think that's anomaly. Okay, let me just mark it as answer.
Mhm.
So yeah, I think let's see if we have additional questions in there. If you have any other questions, please feel free to use the Q&A section. And in the meantime, we are going to see if then the following panelist will join. And that's it. So thanks, Gil. Anyway, while we wait for
Thank you.
additional questions for the session, I think it was very insightful. Regarding you've asked about the presentations. Yeah, we'll try to get all of them after the event. I will try to share them. So definitely, we'll try to, so you can get all the value that Gil and the rest of the panelists will show us today. So another question from Marty in the chat is a recent MIT research paper indicates that organizations are not realizing about 90% of their AA implementations, the value of them. I see a majority of professionals agreeing with that. We keep too technical at MVP level without considering industrial scale for the level of data governance legal. What are your thoughts? What are you seeing in the customers about the level of production usage of AI, and how much value are they getting from it?
Yeah, it's an aspect that I've touched on the presentation itself. So on the paper that I've mentioned, like it was like that more than 50% are not happy or doesn't see a low ROI of AI usage, and it's like I think it also combined with the hype of AI. We now want to use AI. Everyone wants to use AI and then think how it helped us. And this causes this confusion. Um, and I think it's really important to carefully check how we use it and also, of course, the cost of it. But even before the cost, on the engineering level to ask ourselves, okay, do we need AI for this? And if we need AI, on which way? Do we throw the entire prompt or the entire action that we want to the AI and let it do everything? I can do a spoiler. No, it will not work, and it will cost a lot. We need to deep dive on each feature and to resonate the usage of AI for it. So I definitely agree with this paper, and I think it's a phase that the AI and the industry is going through right now because the pace of everything is just too fast. And I don't know if it will stabilize, but this is the effect of this AI train.
Yeah, definitely. I think that, there are certain things that you can easily do it, but a lot, I think, especially in enterprise, given the amount of, data and consumption that you get, you need to carefully test it out and measure the cost and the value that you are getting in POC levels. And then evolve, because I think, yeah, most of it is testing and spending and all of that, but some people are probably testing like in production level stuff without measuring in an early stage or in a staging situation, which it's okay to spend same as any other application, but you need to make it in a controlled environment before going into prod, right?